Now in the case 5, if they are approaching, we are considering this is the railway engine is whistling with frequency f0 and moving towards a movable observer, such as it is going with f0, frequency, speed of sound is v, source speed is vs, and observer is coming towards it. They are approaching each other. As per relative velocity law, we know if both objects approach each other, then their relative velocity become definitely vs plus v0. So in the case 5, if we understand the frequency apparent for 5 is f0 v plus, since it is approaching it is plus, and since it is also approaching source it is minus, like this. We can modify this law in such a way f0 1 plus v0 by v upon 1 minus vs by v. I am dividing by v, and by using binomial theorem we can use it 1 upon v0 by v plus vs by v. Put it in up, minus 1, use it, since v0 vs multiplication is very less than v square. So in this case we are getting the apparent change with respect to initial as a percentage is equal to 1 upon v, v0 plus vs. This is very important for IIT point of views. In the similar manner, if we move away from each other, such as after meeting towards, the source is going this way and listener is going that way. So in this case 6, we are discussing after meeting, railway engine is going on that way after whistling and the listener going to that point. So in this situation, although the relative velocity will be taken as negative, it is moving, but since the listeners and observations with respect to source is a positional changing vectors, that is why we get the equation as this: f6 apparent will be f0 v minus v0 upon v plus vs. Use binomial theorem as I used here and go to the minimization. You will get that f apparent in the sixth will give you f0 into 1 by v, v0 plus vs, but in negative form. Means if you get the percentage through it, directly you can write down this is f0 percentage del f is that one. So this is the another things, another law we are getting when you are using, they are moving away from each other. I take 3 steps together. Please go through your equation and prove it. Equation will come like this. The question belongs to your syllabus. For the simple entrance examination will be in these 6 cases. But I am going to discuss another good and important cases for IIT and All India Institute of Medical Science test, such as if both are moving towards in some directions. If one wall is come in between them, such as in marriage party you will see one man is sitting on the car and horning, and the band is also getting this horn, as well as a man behind this man walking, he is also getting reflecting away from the wall. What will be the cases like that? If the sound is be in horizontal circular motion or it will be in vertical circular motion, what will be the position of the listener? And if the listener is not on the same line joining between the source and listener, if it is on the same plane but not in the same line, such as a railway is whistling on a track and going like this way, but a farmer d distance away from the rail track is listening the sound, what will be the positional change in this system? So other cases, whatever I am discussing, that is for only IIT and PMT testers. Although this question also belongs to that test, but the modification law, as you know, is most important for IIT. So case 7 is about if the position of the source This is the position of the source and that is the position of the listener. If they are d distance apart from each other and the source is moving on this track and the listener is getting the sound from different position at different angles till the angle becoming 0 degree to each other, what will be the apparent approaching frequency and what will be the apparent receding frequency. So this is case 7 and I am finding application of it as well as equations.